Hi everyone, welcome to this Tonic Talk by Datatonic. These are a 1-hour digital talk where we invite some of our top clients and partners to speak about our most impactful projects. My name is Jamie Curtis. I'm a strategy and engagement lead at Datatonic. And today we'll be covering personalization at scale with Sky. It's my pleasure to introduce Hamish Neugebauer, a Scrum Master at Sky, Aidan Dunlop, machine learning engineer, former software engineer at Sky, and Thomas Gaddy, a data scientist and machine learning engineer at Datatonic. Before we get into the actual talk, we've got a few housekeeping rules. We'll have a fireside chat for approximately 40 minutes. And during that time, we'll be sending a few live polls for you to answer in the polls tab. If you have any questions for the speakers, please send these through the questions tab, and we'll reserve these at about 20 minutes at the end for some live Q&A. Firstly, I'd like to start by clarifying the term personalization at scale. I think in theory, one-to-one personalization means delivering the right message at the right time through the right channel and to the right consumer. But in practice, we all wish it were that simple. Getting the right message requires analyzing massive amounts of data sources, be that demographic, CRM, website, search, social, and connecting the most relevant product or content to the individual user, all in real time and at scale. Luckily, we have a few clients like Sky who are leading the way in this. So our first questions to you, Hamish. What does personalization mean at Sky, and how has data and machine learning enabled this in practice?
Cool, cheers, Jamie. Hi, everybody. So personalization has always been a big part of Sky and its strategy, especially in the broadcast section. What's brought us to kind of where we are now in terms of AI and ML and our engagement with Datatonic is there's an explosive move towards leveraging AI to do this better and on a more personal level. For instance, we can be more personalized or more granular in how we're personalized. Without ML, we traditionally do things, we might do segmentation, maybe, females between 25 and 35. That's a pretty broad brush to try and work out what that individual might want to watch next in our space. ML is enabling us to become more focused on the individuals and in a more precise manner and in a scalable way. So we're going to get to that point where we can do the personalization for myself or for Aidan or for Thomas or for Jamie without having to have a developer write each individual piece of code around that. I'm sure you're all aware of the benefits of that. So the challenge around that and the reason why we really are trying to explore this, and then we'll talk about a lot of this in this talk, is the tooling and processes around how to do this in a repeatable, collaborative fashion feels like it's lagging behind, or even the processes. So the challenge in AI for me today is investing in all of these tools, investing in experimenting in how to use those tools for the processes, and then using AI to solve problems more easily and more reliable, and balancing that in a way that's not burdensome. I think traditional software development went through this, as we went through the CI/CD revolution, as it were, and now AI and ML is a good pattern that we want to follow, but the tooling is catching up, and of course, as I'm sure you're all aware, ML adds a lot more complexity to that puzzle, certainly in some new and interesting ways that we're still discovering. So hopefully that explains it to you, Jamie.
Yeah, it does. It does. I agree with the comment section. I think we've leveraged ML quite well so far, and hopefully that'll be a lot of the discussion today. It's interesting you touch on the step changes that ML has brought to personalizing recommendations. I think so much of personalization and the rise of personalization as a trend in businesses is due to things like recommender systems and providing a tailored experience to each customer. The likes of Netflix, obviously Spotify, Amazon, Google, they certainly pioneered that ability to serve recommendations to millions of customers. But you've also touched on some of the key challenges around scalability and collaboration, which hopefully is our first live poll coming up. And so, Thomas, I wondered if you could expand a bit on the challenges faced by organizations trying to productionize their ML models.
Yeah, sure. Thanks, Jamie. Hey, everyone. In terms of productionizing ML models, what I kind of see or what I feel is the difficulty kind of centers around this inherent tension between a data scientist who wants to rapidly experiment, who wants to move fast, who wants to break things, mess around in a Jupyter notebook, see the output, see the data, and the sort of engineering rigor, the precision that you need to get sort of a stable machine learning model out into production. And so while the data scientists, they want to experiment and get those models out there as fast as possible, you also got to remember that once those models are there, we actually want them to maintain their performance, or ideally even get better, right? We definitely don't want them to just get out into production and then crash and burn. So basically, model degradation is kind of like inevitable due to just a messy, changing outside world. We're relying on the outside world, and especially for things like recommendations, right? All of our tastes are constantly changing. So how to handle that difficulty like gracefully, that's the real problem. So at Datatonic, for example, we have both a data science team who's more focused on sort of the experimentation and the designing of algorithms and sort of trying to proof out different use cases in machine learning, as well as a fully fledged sort of MLOps team that's more focused on the productionization and optimization and automation of the pipelines around those models and trying to get them into production in the most efficient means possible.
And for the benefit of the audience, could you define in your head what is MLOps?
Yeah, sure. In my mind, I think MLOps is sort of a constantly or maybe rapidly evolving set of best practices and communication guidelines. I think it's really sort of a mindset, and it's backed up by like a series of technologies and tools that we'll get into later. But to me, it's very much like DevOps, primarily concerned with automation and standardization of machine learning processes and trying to drive alignment between a lot of different teams, right? There's a lot of moving parts, data scientists, data engineers, SREs, machine learning engineers. And there's also a lot of different sort of tasks in the machine learning lifecycle. So data collection and pre-processing and model training, evaluation, deployment. So how can we unify all these teams? How can we sort of unify these different tasks to create sort of one, overall workflow or process? Actually, I think Hamish, though, you're probably a better person than I am to talk a little bit more about just how you see MLOps being related to DevOps and how you see MLOps within the context of Sky.
Yeah, sure. I think what you've touched on there is pretty critical. MLOps, the goals and where we're trying to get mindset-wise are really very similar to what traditionally we think of as DevOps. It's about collaboration and communication. SREs, data scientists, data engineers, ML engineers, all sorts of different departments and skill sets. I think with MLOps, the way it is, the complexity around it and where we are, it's about that communication and finding ways to work together effectively. I think where DevOps differs a little bit is you're trying to merge all of that into one team or make it as close as possible together and have that cross-skilled functionality to try and break down those barriers. I think we want to get there with MLOps, but I think we recognize that that's a bit trickier. But both DevOps and MLOps have this huge emphasis on automation. And in a way, it's even more complicated with ML. You've got the dev and the ops, but then with ML and data science, you've got this added bit of all of this data that's alive, it's moving, it's changing, it's challenging you in different ways beyond what you would think of in a traditional. I've got Scala teams that work for us. It's tricky enough to develop a piece of Scala code that is reliable and does something expected and test it. Trying to do that with all these other moving, living parts around it is that extra layer of complexity that adds to the challenge. At Sky, I think what we wanted to do, and for our recommendation engines, we had a bit of a wish list, I think, once. We've gone through a few models, and I'll let Aidan explain sort of the pain about why we've come to this vision and why we want to improve on it and where we learned from. But we wanted to make sure that experimentation was consistent and repeatable. We wanted to add visibility and transparency around the experimentation, the opportunity to make things explainable. We wanted to make sure, Thomas touched on the operation side and this friction or this difference of mindset between the traditional data science and the engineering people who are sort of sitting and yeah, but I've got to look after this in production. We need to be able to monitor it both on the production side and even while it's training. We want to catch things like data drift, accuracy tracking. We want to understand why a model gave an answer and be able to make sure that's interpretable. So when a stakeholder has a question, we can talk them through it and learn from that. And then it's automation. So everybody can focus on delivering the value and take away as much of the pain around that. And really the final thing on our wish list, and I think this is probably our biggest guiding star, is creating an appealing collaboration space for people with all of these skills to come together and deliver value together with as little friction as possible. And that's tricky. No, I guess you've gone through some of the pain, and you can probably explain where we've come from. So I'll maybe let you do that.
Yeah, I think a good place to start is the ML maturity levels that Google have developed. They kind of summarize where we were in our MLOps and personalization journey. There's quite a few frameworks or levels like this. I know Microsoft have their own ML maturity model. And there's even a Medium article called 7 MLOps Smells. But they all sum up kind of the same thing, which is where companies might be with their machine learning and where they need to go in order to productionize their models. What was probably most interesting for us is that before we started with Datatonic, we checked all the boxes for level 0, which is like immature ML. We realized that we were very good at doing ML very badly, which was eye-opening for us, but actually helped us eventually. So what level 0 means is that our processes were highly disjointed and mostly manual. I think there might be a poll coming up about some of these level 0 attributes, but I'll go through them. We pretty much ticked every single one of these, so don't worry about admitting that your company might be the same. But yeah, as others have already alluded to, there was this concept of throwing it over the wall from a data science to an engineer, where the engineering team might pick up a black box model that a data scientist has created and wrap it up in a service and then somehow support that service. We were directly manipulating model artifacts, which is the first checkbox. And so someone would create this model via Jupyter Notebook and then maybe send it over Slack. And I think you could probably, this is quite similar to how maybe 10 years ago or 20 years ago, someone would email you some code and you expected to edit it and then send it back, and there's a lot of back and forth. And at least there are all sorts of problems. One of them is difficulty recreating data transformations and pre-processing steps during inference. So whatever the data scientist does to their data when they're training it, we need to do exactly the same thing at serving. Otherwise, we're at risk of training and serving skewed. There wasn't any drift detection mechanisms in place. If the data that we had to train the model doesn't match the data that's coming in at production, then clearly the model isn't going to perform as well as it did. And I think that's a challenge when a data scientist shows off their model to stakeholders. It might seem great at the time, but then actually when it's in production, it wouldn't perform as well as it did. So another checkbox is experimentation was done on a static and batch data set, which probably didn't match the data that was actually available at production, which is definitely a huge problem. I think lots of these kind of problems are just manual issues. They're manual tasks that we were doing. We were having model versions tracked manually, doing experiments manually, and the retraining was always done manually, which I'd actually argue isn't great science, let alone great engineering. So that's somewhere we definitely need to improve. All these models were built with a kind of good enough accuracy. So it was just assumed that a good F1 score or high recall would mean it would be great in production. And kind of there wasn't much thought around custom metrics for a particular use case. As Jamie mentioned, I've come from a software engineering background, and so kind of the biggest problem for me was that the training code that we used wasn't modular and wasn't tested. And it's fine from a data scientist's point of view because they're not there to write software, they're there to think about data and how it can be used. But if we were to productionize the stuff that a data scientist might create, it needs to be production ready. There are so many great machine learning libraries out there, but they can be quite different. A machine learning model developed by sklearn, the code for it could look very different to the code from TensorFlow, which makes it quite hard for us to support all these models and to kind of debug both of them at the same time. And I think the final point was deployment refers to just a prediction service when you're at level 0. It just refers to you wrapping your model behind an API and then seeing what happens, as opposed to an entire machine learning system of training and then monitoring how that training is going, and then ultimately how the serving goes with the models that you create. So this probably paints us in quite a bad light. And I'll try to describe a bit later how we've improved from level 0. But the end result that we realized was that we had infrequent releases, and we had just ultimately difficulty moving into production. And then even if they made it into production, the models were quite likely to crash and burn because there was no automation, no monitoring, and no retraining, automated retraining in place.
One thing I will say here is, like, it is very intimidating, right? When you see that checklist and then, it's like, oh, one by one, and then you're just looking like, oh, no, this all applies to me. But it's also, in a way, it's really nice, right? Because it gives you like a roadmap going forward. You know exactly what you need to tackle. It's like, okay, I'm doing this. I need to stop doing this now. I'm not doing this. This is what I need to do. So it gives you a really like clear path forward. So that's really helpful, even though, at the time it's,
I think for us it was massively sobering, but at the same time it was kind of inspiring as well, because we're like, okay, it's not just us, and yep, this is a whole bunch of things that we kind of thought we needed to fix. We hadn't quite put it as succinctly as the poll and the Google process that Aidan's talking about did. So it sounds quite negative, but it was a positive turning point for us, and it's where we went, okay, well, let's work out how to step forward and progress on this now.
Yeah. I think the fact we're here today as well shows that it's not only a clear roadmap, Thomas, but somewhat achievable one as well. And I guess Aidan will touch on where we are now on later on. So I guess this brings us quite nicely onto the actual engagement itself at Sky, which, for context and in a nutshell for the audience, was building out an MLOps platform, applying best practices and tools to take their ML models into production and facilitate personalization at Sky. For context, at Datatonic, we've worked with Sky for a number of years now, transforming their data and AI capability across different teams, all on Google Cloud Platform. So this has gone from supporting Sky's cloud data migration to setting up their real-time streaming analytics platform and improving their content analytics tools to various AI and ML innovation projects. In our most recent project, we've worked together on building out a platform capable of supporting a number of different models, including natural language models, easy for you to say, and recommender systems. But before we delve into the project finding and results, Hamish, maybe you can discuss a bit more about Sky's presence on GCP.
Cheers, Jamie. Not so natural language even. I can't do it either, so it's all good. I think so. Sky has a presence on Google. We have a presence on AWS. We even have a footprint on Azure. We have some engineering tenements that ask us to be cloud agnostic where possible. We don't make life hard for ourselves with that, but it's something that's always in the back of our mind. The reason that a lot of Sky's activity around AI and ML, for instance, is on Google is ultimately that's where our big data lakes have landed. So we have a strategic data platform that lives on Google, and where most of the information that we're interested in either is or will be in the near future. And a lot of that, as Jamie alluded to, is real time. There's lots of managed services that made it easier for that data lake to evolve there and survive there and grow there. From our perspective, a little bit more selfishly in terms of AI and ML and this platform we're trying to build in this collaborative space, it made sense for us to be close to the data sources so we can get access to it more easily and remove that friction point. It made sense for us because of some of the scalability options that we have from Google. AI platform, something I'm sure you'll hear mentioned later on, that was one of the reasons we made some of the choices we made and gave us some flexibility we wanted. And also, obviously, because of the size of customer we are with Sky, gives us a big opportunity to have a very strong partnership with Google. We've had some great conversations with them about how they do AI and ML. There's some really exciting stuff in their roadmaps down the line that we hope to leverage, or certainly maybe even influence and steer to help us. And that's pretty much in a nutshell kind of why we use Google and why we will continue to use Google until otherwise. Yeah.
And to confirm, and for members in the audience that maybe aren't on Google Platform, AI Platform is a tool within Google Platform, right, for productionizing the ML model lifecycle.
Yeah, it's a managed service, so it can take away some of the pain of having to run it yourself.
Sure. And so, Thomas, what have Datatonic and Sky done to adopt MLOps during the engagement?
Yeah, sure. I think later we'll get to maybe some more like concretes and maybe like exactly how we went about, adopting these MLOps best practices we're talking about. But I think maybe it's useful to think about a couple of things that we really tried to work on from the very beginning, which are sort of critical for MLOps. Maybe you can think of them as like prerequisites before you actually get into anything else. And I think the first is sort of establishing ways of working both within and between teams. So we've talked a little bit about processes, workflows, communication guidelines, sort of also establishing the right mindset, especially within data scientists who might not be used to working in that sort of like DevOps mindset, as opposed to someone like Aiden from an engineering background is probably very used to that. And then in addition to that, also the tooling. So I think there tends to be a lot of focus and a lot of like hype around all the different tools. And that's, maybe from organizations who've seen how much trouble they've had getting ML into production, and they're kind of looking for a silver bullet, like to solve all their problems. And what I will say is, like, while all these tools, some of them are really great, and while they're important, I think the sort of communication guidelines and creating and following best practices kind of comes first, really. And I think we actually kind of experienced that at the beginning of this project, where there maybe was a little bit too much focus on the tools at the very beginning. And the result ultimately wasn't necessarily that much better than what it was before. It's like, now maybe if you just focus on the tools, maybe you have like a end-to-end pipeline that's being thrown over the wall from data scientists to engineers, which might be a little bit better, but if it's still not tested and it's not really production quality code, and the engineers still don't really know what they're productionizing, it doesn't make it that much better, even though, okay, I guess you're dealing with a pipeline now instead of a model. So I guess it's good. But the point is, having all those great tools won't necessarily prevent like poor company culture where data scientists and data engineers and ML engineers aren't really communicating with each other. So like, just as in DevOps, it's like kind of mindset first, and then the tools are supposed to sort of solidify and facilitate the processes you develop. But all that being said, what we really liked is by choosing some of the right tools, we were able to get a lot of just like easy wins. But maybe before talking about that specifically, Aiden, you can probably talk a little bit about some of the standard sort of DevOps software tooling that you use that are common within Sky, and maybe what you were also like looking for in terms of MLOps tools.
Yeah, sure. So Sky uses lots of the standard DevOps and software engineering tools that you'll see in many tech organizations like Git, Jenkins, Docker, Kubernetes, Prometheus, Grafana. I could keep going. And yeah, because I've had that traditional software engineering background, I've seen how valuable those tools can be, and felt like as I moved over to ML engineering, we must be able to use these in some ways. So yeah, these tools are part of our MLOps platform, but we are also looking for tools that help us with more of the ML side of MLOps, which is only natural, I think. But when we're considering whether to use these tools, we think a lot about the wish list that Hamish was mentioning earlier, and we think how they can direct us on this ML maturity path, and actually ultimately deliver value from the models that we create. So we ask questions like, how can it help with standardization, visibility, scalability, that sort of thing. But we also had some additional things that we're looking for, I think. We want to take advantage of open source tooling that would integrate well with our GCP services, as well as our existing tech stack. We want to kind of have the best of both worlds by allowing us to take advantage of managed services like AI Platform on GCP, if we want to or if we need to, but don't necessarily lock us into a single cloud vendor. We use both AWS and GCP at Sky, so we want tools that can kind of leverage between the two and don't get us stuck in one place. We also want tools that help promote best practice, and admittedly, what we're trying to do is quite bleeding edge, so there isn't always a best practice, but we have we have ultimately found some tools that we like and come to a decision on why we're using them. So Thomas, I don't know if you want to talk more about the specific tools that we chose.
Yeah, sure. And I can keep it pretty high level for now, but of course, if people are interested, I think we're more than happy to go into that in more detail during the Q&A later. So you can just drop questions in the questions there, and we can get back to them later. But if we think about it first in terms of the training environment, I think our main goal there was we wanted tools that would both sort of facilitate experimentation and support ML training pipelines in production. So if you're using the same set of technologies and tools, both for, you can call it maybe like late stage experimentation, where you're just comparing some different models and trying to track metrics, and for the actual pipelines running production, if you're already using the same tools and the pipelines basically look the same, then you're basically halfway there to production, right? So that really helps. And so in particular, we ended up standardizing on Kubeflow pipelines and on TFX for now. So can just describe briefly like a sentence about each, but with Kubeflow pipelines, what we got was sort of a container native workflow engine. So we get all the benefits that you get with containers, that portability and all the workflow tasks are sort of encapsulated. And Kubeflow pipelines allowed us to orchestrate those jobs on Kubernetes. And we also got a great UI, so we can use that for managing and tracking experiments. I saw that there was a question there about weights and biases and some other options, but we found that the UI there was quite nice for managing and tracking experiments and jobs and runs. And what we got with TFX was a way of authoring pipelines that sort of helped enforce best practices. So it allowed us to sort of build data validation and model validation and infrastructure validation steps into the training pipeline itself. So these weren't sort of like external to our training process. It was like inherently part of our training pipeline. You have to check that your data is good. You have to check that your model performance is satisfactory before you push it anywhere. So basically, like between these two tools, we get a lot of consistency and standardization and easy experimentation and that transparency we wanted. So a lot of these sort of wish list things we've mentioned before. And then of course, both of these technologies are open source, but they integrate really, really nicely with GCP. So if we want to, we can kick training steps out to AI platform or pre-processing tasks out to Dataflow, for example, so you can get that like massive scalability on pre-processing. Don't have to worry about provisioning hardware accelerators for training jobs or anything like that. On the other side, though, so that was like kind of the training environment, but at the end of the day, it's deploying the models that actually gives you the value, right? They have to actually be there and serve real requests and interact with other systems or with customers, and that's what delivers value. So we had to kind of carefully consider the tooling options available there. There we focused on, or we decided on KF serving, basically because it provided a very simple way to manage the complexities of ML deployments. And because it runs on Kubernetes, it's also cloud agnostic. So that was like a big plus for us. What I will say is that even though we've really enjoyed these tools, it hasn't just been smooth sailing. So they're still rapidly evolving, maybe a little bit immature in some places. I don't know, Hamish, like what did you think when we were talking about these tools, and how did you see that sort of evolution in the MLOps tooling space?
Yeah, I think it's moving quickly. That's probably the most important thing I can say for anybody who's trying to find a path through this at the moment. I think you won't find a silver bullet, period. I just don't think there is one. I don't think there is one for software development, and I'm pretty sure there isn't going to be anything even close for ML for a long time. What I would say is the way that we work with Datatonic wasn't terribly traditional for working with a third party. Thomas is as much a member of the team while he's been working with us as any of the other Datatonic colleagues and the Sky colleagues. And we collaborated much more closely on trying to find tooling that met our guidelines in terms of what we were talking about earlier when we were talking about some of the things about being some platform agnostic. And we tried to match up the tooling with the processes we were trying to put in place. I think somebody asked a question about, what are the technical and business complexities around putting together these processes. And I think that the true complexity around it is actually bringing the people together and getting them around the same table or the same environment and building these processes together whilst we're making some of the technical choices we made. What I would say is we were a little naive early on, and we sort of looked at some of these technologies and we thought, great, the sticker says it's going to do everything we need it to do. That's the obvious choice, right? And we went down that route and we went, ooh, there's some bits missing here, or the documentation doesn't actually tell me how to do this, or even if it's possible. There are gaps, and it's a bit painful. And a big part of what we've done is making sure that we're not boxing ourselves into a corner with the choices we make. And I think that's probably one of the most important things we are doing and we've done. What I would say is it's exciting. Things are moving rapidly and it's keeping us on our toes. But I think every week when we come back and we revisit a decision we made earlier, or we look at the technology we chose earlier, we went, ooh, it could be better. They're growing and they're getting better. And the value they bring to unlocking this huge value we have in these data lakes that I think probably all of us have is definitely getting pretty exciting on a day-by-day basis almost.
Yeah, it's really interesting. I think touching on all of those things, particularly, so the tooling itself is amazing, but as you mentioned, Thomas, I think touching on the requirements outside of that as well, the close collaboration that we've had as Datatonic and Sky, but then also the team, the machine learning engineering team at Sky have had with the different data science groups and the SRE team as well, is really, really key. I wonder, Aidan, so could you tell us where we are now, or where Sky is now on their kind of MLOps journey, and then also maybe touch on what's next for Sky?
Yeah, sure. I guess we can refer back to Google's ML maturity levels. So like I said, we're at level 0. We're aiming for level 2, so there's 3 different levels. Level 2 is kind of where everyone should be. We're definitely not there yet, if I can make that clear. But we are making strides towards it. I'd say we're no longer a team that picks up a Jupyter notebook and does something with that. But we actually work with the data scientists that produce those notebooks to help them deliver the models and encourage them to think like engineers do, so that ultimately they can support those models. So we do currently have, and through working with Datatonic, we have machine learning pipelines that have modular containerized code with a whole different levels of testing throughout. So we have unit tests on just feature engineering steps and more traditional software that sits around the ML. We do have what we call machine learning unit tests, which example is, can you quickly verify that your training causes your loss to go down on a small sample of data? And we want to be able to do that very quickly as a style of a unit test. But then we do have full pipeline end-to-end tests that run through the pipeline with a smaller set of data, but do the whole thing, just to verify that it does what we think it should do. And we have integration testing for the inference service that we create. I think one of the other things that we need to do for machine learning is that we have testing within the training pipeline itself. So I think Thomas touched on this earlier. We have data model and infrastructure validation. This is kind of part of the area that we're not really there yet. There are TFX components that are called data validation, model validation, infrastructure validation, and they're great. They don't exactly match some of our use cases yet, so we'd like to work with open source software and help contribute back to them. So that's kind of one of our aims. But what TFX does allow us to do is to create reusable custom components. We're able to add our own specific validation components, for example, that we can control and we can fully test and ensure that they're production ready. And then we can reuse those components again and again in different projects. We potentially might have lots of different projects that want to use machine learning at Sky, so we need a way to kind of standardize the tools that we're using. And TFX definitely helps us with standardization. It's just a way to have a symmetry between what we're doing in the experimentation land and what we're doing in production, and to ensure that the pipeline implementation is exactly the same all the way through. We're still working on having CI/CD and GitOps embedded through the entire process, and having a CI/CD and throughout the training pipeline and throughout what's happening on the inference service. Trying to use our existing CI/CD tools that we use for traditional software can be quite hard because there are some gaps there. So we're talking about either extending our current CI/CD tools or using others. It's currently what we're looking at. Kubeflow is great for orchestrated experiments and does rapid experimentation. Data scientists can do, and also a centralized place to record and visualize results. So we're kind of halfway there, I'd say. One thing that we've struggled to find is a good monitoring solution. This is quite leading edge, I think. Machine learning monitoring can mean different things to different people, and the kind of solutions that are out there already are maybe more focused on simpler numerical solutions. We have natural language processing models, as was mentioned, that are kind of more harder to monitor. Sometimes you could argue that they're subjective in how well they're performing. So we need a way to objectively define how well they're performing. We have come up with a kind of proof of concept solution to monitor our training pipeline, and hopefully it will work well, but that's to be decided. We would like some form of automated test to detect drift. I think someone asked a question around that. It's definitely hard, and maybe Thomas, you can talk about that more later. But if we can work out a way to detect drift, we then want to use that to automatically retrigger training, so that we can handle that drift. And maybe it wouldn't even stop the pipeline. The pipeline could continue, but we know that drift has taken place, and then we can analyze it offline and work out ways to deal with it. I'd say my kind of biggest want right now is some form of feature store. We want to be able to reuse the features that data scientists are creating again and again, and just to provide a kind of clear front end into the data that we're using. We have a huge data platform at Sky, and I don't think we're taking advantage of that. And I think feature stores is a way to take advantage of that. So ultimately, we want to be in a place where data scientists can continuously push updates to their model training pipelines, and then we as the machine learning engineering team can monitor the performance of those models effectively. And hopefully this leads to faster time to production and less risks of models crashing and burning. Like I've said before, come from a software background, and the DevOps mindset there is well understood, and the benefits are kind of obvious. And we recognize how MLOps can help us in a similar way, so that we can quickly ship these models to production, and probably more importantly, keep them there and maintain their performance. But the key difference is that DevOps is mature, and MLOps isn't, because of that extra layer of complexity. So yeah, we just need to work towards a place where we have more mature MLOps principles in place, and then hopefully it means our data scientists can spend less time on the more manual processes and maybe tedious tasks, and free them up to do the actual cool modeling work that they'd rather be doing.
Yeah, of course, that's the goal, I guess. I suppose as an ML engineering team, the data scientists are the customers of our work. So if they're happy, then I suppose we should be too. I guess to summarize, I think it's been great. So we've made project progress, both from a technical standpoint around choosing and implementing tools, from an engagement standpoint around the collaboration both together as Datatonic and Sky, and then also within Sky internally. From a strategic standpoint, by getting sessions in with data scientists and SREs that we mentioned, and also probably most importantly from, I think, a business standpoint. So being able to get models in production faster and with less risk increases the engagement or the revenue ultimately that you drive from those models. I think from a Datatonic perspective, we've been extremely glad to support Sky on advancing their personalization and MLOps capabilities. And it definitely takes the team. Thomas, as tech lead on the project and having been on the project from day one, any words of advice that you can give to the audience about how to kickstart an MLOps transformation successfully?
Yeah, sure. I think, I mean, we kind of have already touched on it to a big degree, but I think the mindset thing is the biggest thing that stands out. And I mean, maybe this is obvious for newer companies, but I think one thing, it's tough to be a data scientist in a company like Sky where there's so many established business processes, right? Because it's sometimes maybe in a big company like that, it can feel like low stakes, the data science work. It's not really impacting any existing processes. But as we noted before, right, like personalization is just becoming a bigger and bigger part of Sky, and therefore AI and ML is becoming a bigger and bigger part. And therefore, like, we can't really afford to have sort of the existing processes that we had before, and we can't afford to have ML models that could potentially be driving a huge a ton of revenue and be driving a big part of the business. We can't have those degrading in production. So that it requires a shift in mindset where you start to realize, like, okay, oh wow, what I'm doing now is actually really, really important for the customer experience, and I got to kind of take this seriously now. And I think that's the main thing, and it can be kind of tough when you're in a business that's already so well established, that already has those processes in place. And for this particular project, it's been kind of nice, right? Because working with people like Aiden and some of the other guys and teams that come from a software engineering background, they've, I think, fully already adopted this mindset, right? So it's very nice to work with them, and they teach us plenty of stuff too about DevOps engineering mindset, and then together we can kind of like craft processes and mindsets that we think it's important for the data scientists to have as well, and hopefully try to like let that permeate through Sky, the larger Sky organization.
Yeah, definitely. Hamish and Aidan, what's next for Sky from your perspective?
So I think Thomas sort of touched on it and hit the nail on the head. It's helping that mindset grow and nurturing that mindset. I think it's also about us having an open mindset to understand the data scientists as well. It's not just about the data scientists having to be open-minded and get engineering. And I think that was one of the key things that we got out of working really closely with Thomas in the team, where maybe we would have made assumptions, and we touched on it in some of the pain points we had earlier about, hey, we've got this, everyone's working with pipelines now, and they gave us a pipeline. And all of us in our team were sort of thinking, oh yeah, cool, we're gonna have a pipeline, it's got some tests in it and everything. And we got it and went, yeah, we should have seen this coming, really. Like, we would obviously write tests, but we didn't do this, and we didn't actually help those data scientists understand that expectation. And now we're going through a process of kind of working with them and going through that, sort of helping, sort of showing them, or leading by example is what we want to do. Thomas has done some really great work creating example documents and things that are kind of not quite golden standards, but certainly a guiding star and a starting point to help people understand where we want to go and what we want and how we want to collaborate. So really for us, it's cementing the knowledge and the processes that we put in place and continuing to build on them. It's drawing that wider AI ML community within Sky with a compelling offer. I think somebody asked me a question about, how do we manage scope creep? And I think where we want to get to with this platform and these processes is to democratize the ownership of AI and ML capabilities within Sky to the data scientists and the people who are expert in what they're trying to do with the data and what problems they're trying to solve, in a way where they need to know as little as possible about the moving parts, but they can still understand it and they can still affect it. So lots of config-driven stuff, lots of automation, fairly traditional to really what makes sense for a lot of software engineers. But for ML is complicated. There's nothing off the shelf to do it for us yet, and we're working out how to do that. We know there's no silver bullet, but at the end of the day, we want to lead by example, and we still have some huge challenges to tackle. We probably still have some huge challenges to discover. Aidan will probably mention one shortly that we kind of discovered partway through and went, oh yeah, this is a big problem. We didn't even think about if we're going to have to solve this problem. We just didn't even think it was a thing. So yeah, I think that for us is to continue growing and to be adaptive and be open-minded.
Yeah. And Aidan, I'm conscious on time and giving a decent amount of time for questions. So it may be a minute or two. What's up next for Sky from your perspective?
Yeah, I'd say machine learning is only as good as the data that it uses. So you can have all the fancy algorithms and clever tools like the ones we've mentioned today, but it will be nothing without a solid data foundation. So what Hamish is alluding to is we need a feature store. So that's the next big thing on our roadmap. So hopefully make the most out of Sky's data platform and just help make data scientists' lives a bit easier.
Perfect. Great. I think that brings us to the end, wraps up the fireside chat part of the Tonic Talk. We'll make sure any material is available afterwards. And now we'll take some questions from the audience. I wonder if we maybe run through some specifics. Let me just run from the top. What do you use for experiment tracking? From Daniel. Comet, Neptune, TensorBoard, DVC.
Yeah, there it's TensorBoard and Kubeflow pipeline. So for like one single run TensorBoard, but across different runs.
Yeah, and I think I answered there as well on a grander scale of the experiments for us is like the AI and ML is a small part of the customer experience. So they become part of an experiment in our customer experience as well.
Yeah. And I guess on the next question, Daniel, and how did you reason when choosing? I think worthwhile saying we made quite a few charts, particularly in the first stage of first phase of the engagement, around utilizing or comparing different tools based on selection criteria. So for TFX, it might have been the level of standardization that it provides versus Kubeflow pipelines, which is around the level of customizability that you can use. And there's a lot of those, and we can share those afterwards, those charts for tool comparisons.
And one thing I would add there is like we made a lot of decisions that are based on sort of Sky's organizational culture, like sort of idiosyncrasies within Sky, and those choices definitely aren't going to be right for everyone, right? But we at least tried to reason through it and think about all the different dimensions of each choice and said, what's more important to us as an organization, as an MLE team, right? So if we really value standardization, that's going to be a different tool compared to another team that really wants some flexibility, and they are maybe more into more like research ML models. So they really need maximum flexibility. So that's how we sort of guided our decision making.
Yeah. Next on to Mike Lombardi. So TFX and Kubeflow have their own standards to follow. How do we allow custom models to coexist in the same MLOps platform?
Yeah, I'm not sure I followed the question.
I think this is a little bit around. So we had a conversation internally, sort of along these lines. Part of the reason we chose TFX was we liked the fact that it was quite opinionated and it discouraged some of this. Part of that is because I think we felt that we were kind of immature in working out how the heck we test this, and TFX brought with it a lot of that opinion forced us to do things that were good practice. So model analysis, the data analysis, wrapping that in kind of automated assumptions, and then proactively doing things around that is something that TFX pretty much forced us to do. We had conversations with data scientists, and a lot of them were like, yeah, we want to use lots of custom stuff. And we kind of went, okay, but is there anything that TFX doesn't do that you have to do custom? And in a lot of cases, TFX could do what was needed. I think one of the technology choices we made was around Kubeflow pipelines. Tom's, Aidan, correct me if I'm wrong. And that does give us the option to allow some of these custom options down the line. Yeah. I think we've spoken about this in the team more recently, and it's like, if we were doing that, it would be a case of, it would have to be something that's reusable. If it's going to be scalable, we can't have a custom component for every, or several custom components for every different AI challenge we tackle. So there's a balance to be found there. And I think as we get comfortable and in the habit of using TFX and its opinions forcing us to write tests, do good model analysis, do data analysis, then that mindset will naturally flow, where if you're building a custom component, you go, oh, yeah, I need to do some model analysis or some custom analysis. Okay, I need to think about this. So it will be thinking about it more naturally. Hopefully that makes sense.
The only reason we kind of will need a custom component is because there's a gap in the tools that we're using. So we shouldn't just create it once. We shouldn't just hack it around for one particular use case. We should make a solid, reusable thing that we can use again and again to address that gap.
Yeah. I'm just looking through questions. So how do we track drift in more real time once the model is deployed into production? So about monitoring and tracking drift in real time. Maybe Thomas?
Yeah, sure. I mean, it's a really interesting question. And what's interesting about it, right, is that fundamentally it's sort of a statistical question. So you have maybe say two different data sets and you want to compare, like, are the distributions in these data sets shifting? And then you got to think a little bit about, okay, what are the costs of my different mistakes, like the classic type 1, type 2 errors, right? Because if you're tracking drift in very, very like real time constantly, you might see some sort of strange blips in the data and you might think, oh God, the data is drifting, I got to retrain my model. But then you got to think, what is the cost of actually retrain the model when I really didn't need to? You're wasting a ton of engineers' time. You're potentially kicking off really expensive retraining jobs. And then on the other side, you could wait a bit longer, collect more data, and then be more certain in your sort of statistical conclusions about whether these distributions are shifting. But if you wait longer, then you risk potentially having a suboptimal model operating in production. So then that's when you got to start thinking about like the business case as well. Like certain models within Sky, you can imagine, like big recommender systems in different organizations. Imagine something like a fraud detection model. That's so valuable. You might think, okay, well, this can like never be drifting, right? Like we got to really make sure that the data that we're serving on is basically the same as the data that we're trained on. But in other scenarios, maybe it's a little bit of a low value model, and it could potentially be more expensive to waste the time of engineers constantly like monitoring new training jobs and using hardware for that than it is just to let a slightly suboptimal model operate in production. In terms of like actual methodologies, it's really interesting. So there's a couple good papers out there, can drop them in the chat later, but there's different approaches to this. A lot of them are based on more statistical approaches, whether they be chi-square tests or something called like a black box shift detector. And these are sort of adopted by different organizations. TensorFlow and TensorFlow data validation, they adopt a very sort of specific approach that's quite different from a lot of other teams, but we actually really liked it because it was based on this like sort of need to surface really high precision and like actionable alerts, which we really like. So like we could get alerts back on the drift that were very like precise and told us exactly what was wrong with the data. But yeah, I can drop some resources there later.
So some of the drift that we kind of expect some drift to happen, and we kind of know in advance. So stuff like seasonal data. So our catalog of content changes as people watch stuff depending on the season. So we might notice that more Christmas movies coming in towards December, and that might not be a bad thing that it's drifting that way. So it's not always a case where we want to alter our action depending on the drift, but it's just worth knowing that there is probably a clear reason for those drifts taking place.
Yeah, I think one that Hamish touched on in the comment section, but maybe worth touching on here as well. So how do you prevent scope creep and keep it manageable in scale and internal priorities? Yeah,
that was Ken's question. I think those of us who come from a large organization probably know it's difficult to manage some of that. I think, Ken, you mentioned a non-political answer, which I thought was an interesting turn of phrase. There's obviously a lot going on. We're not the only area in Sky trying to tackle this problem. It's been done different ways. I'd say there's an aspect of health to that. I think we've said there's no one silver bullet, so Sky diversifying its approaches as a larger organization makes a lot of sense. But really, whatever we do and whoever does it, the idea is to get to the point, the same as DevOps, where change in scope shouldn't be something that's scary, because we're able to make such quick iterations that are really low inertia to get to production in a safe and responsible way, to coin the phrase, to pinch Thomas Gaddy's way of saying it, that it doesn't really matter. I think, for instance, the funding models around some of our projects tend to be, you've got to deliver something by a given date. And I think if you go back to sort of some of the agile principles without starting a whole minefield around that, at the end of the day, the business tends to want to solve a problem. And you will solve that problem as well as you can within the constraints that you have around the resources that you have, be that time, money, or whatever. And the faster you can validate that you're doing the right thing, so you can fail fast if it's completely the wrong thing, and then you can make those small iterations. And that scope creep is healthy, because what we don't want to do is spend, and this is one of the big reasons we're doing this, right? We've been, historically, some of our models, the data science team have come up with an idea of a model with some interesting data that we want to do something for the customer with, let's say a particular type of recommendation. And then 12, 18 months later, we finally get to the point where we can do something for the customer with it. And we go, oh, but like all the systems around us have changed, and the customer behaviors changed, and some of the features that we can use have changed, and it's not really going to help the customer anymore. And that's why we want to shorten that time. Yeah,
I think from a Datatonic perspective as well. So we obviously, as an external consultancy, run some complex projects with some of our clients, obviously Sky being one. I think to your question, Ken, so we typically deliver on a more fixed scope, fixed fee basis. But actually with Sky, we flex that somewhat so that we're less focused on hard deliverables and more focused on being able to be agile around the delivery process and the engagement process. And I think that's really helped. And from a delivery perspective, we've had that constant, almost healthy tension of remaining agile versus making sure that we've got a kind of end of engagement view in mind, be that 8, 9, 10 weeks, and finding that balance between where we need to be in 2 to 3 months time versus where we are now and what the priorities are. And so that's a conversation that me as the engagement manager from Datatonic and Hamish as the Scrum Master at Sky have week on week. Just looking through questions. Sorry,
are you looking at the questions or the questions in the chat, Tom? Jamie, because there were some of like official questions that came up. Okay, cool.
Bit of both, yeah. So yeah, on to Aswin. We've got a minute left. Actually, I think we're on time. I've just seen Lisa said we couldn't get through all the questions, but we'll make sure we reply to the Q&A to any unanswered questions via email. Yeah. Perfect. Let's leave it there then. Thanks, everyone. Thanks to the audience for joining, and thanks for you guys, Thomas, Aidan, and Hamish for the talk. I hope everyone enjoyed it.
Thank you, everybody. Take care and stay safe.